So what is MRSA? Now, MRSA sucks. Why does it suck? Well, if you know what a staph infection is, then we're going to simplify it here. MRSA is basically a staph infection. But the thing with MRSA is it's methicillin and penicillin resistant because usually when we see staph infections, it's pretty easy to kill it with an antibiotic because your immune system kind of sucks. It's doing its job and killing it itself. When we see staph infections, however, we usually give antibiotics, kill it off. It's not that bad. You just have to identify that it's a staph infection before it gets anywhere else, and you're good. But with MRSA, which is methicillin resistant staph infections, basically, because I don't want to pronounce the next of that, and I'm very tired already. What we see is it's resistant. It's got ways of producing and synthesizing proteins and enzymes that make antibiotics useless against it. And not all antibiotics are useless against it, which, you think is good. And it is kind of good, because that means we can still save some people, but that's actually also really bad, because that means that now we're making an even worse bug, an even worse superbug, because now we're giving it last of the line, more powerful antibiotics, and eventually it will get resistant to those as well. And the thing is, it's building resistance to antibiotics faster than we can make new antibiotics. So we're kind of screwed. So what we see in MRSA is, I'll put it up on the screen now, because I'm going to be editing this, and that means I'm going to be standing up really late, and I'll be sad. Anyway, is that we see with MRSA is that it happens a lot more with older people, and happens a lot more with males. Not a lot more, but more often with males. And that tells you some things. I have no clue why it happens more with males, and I tried to figure out, and I couldn't find anything. But we definitely know why it happens more with old people. Old people are more likely to be in a hospital setting. One of the big ways staph infections are spread is through when you're in some type of seeing the doctor, having some type of invasive health product in your body, or if you are currently in a hospital with other people around. But that's what we call healthcare associated, or HA. MRSA. HMRSA. Weird. But now more on the rise, we're starting to see CoMRSA, or community associated MRSA, or staph infections. Community associated is when you have prolonged physical contact with other human beings. Because one of the weird things about staph infections is they'll live on your skin almost all the time, and there's a lot of them all over your skin. The only problem with staph cells, and they're fine living on your skin, they do no damage, is when they invade into the rest of the body. Somehow, someone else's staph cells from their skin gets into your food, or a place in your body where it can get into your bloodstream or into your body. Then that's when you get staph infections. Where we're seeing MRSA the most is Brazil, Colombia, Venezuela, and South America. We're seeing it a lot in Romania, and we're seeing it in Malta, and Malta is a small, very small island off the coast of Italy. And that's kind of bad. That's kind of bad because that's not even counting. That's just the top 5. And already we're seeing it get into most of South America, which is a developing country, so there's a lot of population there that don't have good health care, and into areas of Europe. We also see that the United States is one of the highest on there as well, so we're kind of screwed, but that's okay. Just don't get any minor scrape, or you won't die. So now I get to talk about how MRSA, or staph infections, actually get in your body, and what makes MRSA so much worse than regular staph infections. MRSA, first, like I said, is on your skin, and somehow a MRSA infection occurs when it gets somewhere else inside your body. It's not supposed to be there, and it does bad things. So usually your skin can be infected. So if you get a small scrape or a cut, then you could get MRSA if you don't put a band-aid over it, or if you don't clean it out. And this is really kind of easy to notice, because I'll put on a picture of a scrape, and then I'll put on a picture of a scrape infected with a staph infection. And it's going to be disgusting, so Ava, hold on. You can notice by the amount of pus and blood and yuckiness there and boils, it's not a good there's something wrong with that. And from there, that's one of the main ways it gets in. The other main way is through your mouth. You eat something with staph cells on it, and then it gets into your stomach. And this is really bad. So, staph infections can actually do a lot of bad things. And it's kind of scary what they can do. One of the worst things about staph infections is even before MRSA, even before the resistance to antibiotics, they were fairly resistant to our own body's immune system. And why that is two main reasons. First off, staph cells can produce a lot of different bad, not good at all enzymes and proteins and factors. And so the second thing is that staph cells, when they die, unlike any other cell, usually the cell wall dissolves, and then all those little organelles and every other piece inside it is what our immune system kind of eats up and can analyze to tell, okay, how can we kill this thing? But what you see with this beautiful MRSA here, or staph infections in general, is that cell wall does not dissolve. So that way your body cannot get in and eat those organelles. So every time it comes back, it's like you're fighting a new warrior with different strategies every time. And it is the same strategy, but you just haven't remembered. Your body hasn't remembered how to combat that. And that kind of sucks. But first off, staph infections can damage all sorts of different cells in all sorts of different places. You can get it anywhere in which that cell can go inside your body, and it can damage anything that it could reasonably get to by going inside your body. So what we see is usually blood and stomach infections are the first thing that we usually see. So for example, staph infections can synthesize and create membrane proteins and enterotoxins. And we'll talk about membrane proteins first. Membrane proteins first literally dissolve cell walls of all sorts of different things. They're membranes, they're cell membranes. And so it can damage all sorts of cells because the stuff in the cell is supposed to stay in the cell, not go out of the cell, not go going everywhere. And enterotoxins are ones that it can create in your stomach and in your digestive tract, which cause nausea and vomiting. And staph infections are one of the most common places we see food poisoning, actually. So, also, it can produce exfoliation toxins, which disrupt the skin cells. But it's not that bad. It's basically creates those boils, those pus, that yucky stuff around the infection site. It's not that bad, but what you see is you get blood infections, and those are pretty bad because first off, not only can it start attacking the walls and the actual blood cells carrying the blood and the wall of your different blood in different veins, which is really not good because then you're going to get your hand bleeding into your hand, but not out. It's bleeding into your body, which is not a good thing. It's internal bleeding. It's very hard to treat sometimes. Or toxic shock syndrome toxin. Now that's not good. It's one of the most dangerous toxins out there. They can cause fevers, muscle aches, low blood pressure, weakness, and rashes, and it can occur within 24 hours of you contracting a staph infection. And, sorry guys, but it appears more frequently with tampon use in females than anywhere else, so kind of sucks. But that it can produce toxic shock syndrome toxins in a lot of different places in the body. The blood is one of the places we see it, and it's not good because that can shut down your body in up to 72 hours, shut down organs. And if you start feeling that stuff and you have a boil or a thing on your leg by a cut scrape, you should definitely go to a doctor very soon. It'll be bad. But now we see a couple other things that it can make, that it can synthesize. That is one of the main reasons it's so hard for your body to attack. We have, first off, membrane toxins. We'll talk about those again. Coagulase and slime. So membrane toxins or proteins can actually damage the cell walls of the cells, the immune system cells, which, pretty much sucks because then your immune system is getting popped before it can kill the bad guy. And you get coagulase, which also protects staph cells from immune cells. Basically, it kind of coagulates the area around it, so it's harder for the amoeba-like cells to get over there and get close enough that it can kind of start eating it, because one of the things that your white cells do is kind of create this web of DNA and proteins around stuff, around bad toxins or disease cells, and it kind of traps that staph cell or that whatever cell. But and then it kind of keeps it there until you can get macrophages, which is one of the ways your body fights off bad boy things. And the macrophages come and they kill them, and phages are actually really cool, and I'll talk about them later. But what you see is they can change the staph cells have a way of changing and manipulating the proteins and DNA receptors around them so that when the white cells signal for macrophages to come, they don't actually come. And there was an interesting article about this, about how they saw differences in changes of DNA in staph infections and also a severe lack of macrophages area. And then finally we see slime, which is another thing that they can create, which is a biofilm. And this is where MRSA comes in, because you don't see this coming with normal staph cells, but you see this coming, and it's one of the main ways that they actually get resistant to these. It's one of the main ways they are resistant to antibiotics. And basically, it's a biofilm that goes over the staph cell itself. And when the antibiotics come in and kind of wipe everything out, the biofilm will protect it and stop it from being wiped out from the antibiotics, which means that the antibiotics are actually doing a bad thing, because now they're killing all the good cells, because it kills everything. Antibiotics usually kill a lot of different stuff that you don't actually want to die. It'll kill the immune system cells, but not the staph cells, because you're seeing this slime, this biofilm protecting them. So it's not good. And that's why it's so hard. And it's really right now MRSA is not such a problem that it's like all over the news, but it's definitely going to become one in later years if we don't find a way around this. One of the way around this we were talking about is phages, because phages, and I'll link a video at the end, it's really cool. So these cells can lead to a lot of things when they start doing a lot of damage like that. They can lead to paralysis and blindness at the very worst, and even death, as we see with toxic shock syndrome. And but even before that, they can start leading to nausea, vomiting, loss of balance. We see definitely areas in which your body is not doing the right task anymore. You might start losing blood pressure to your hand. You might start seeing your entire body's blood pressure go down, possibly. It can attack so many different areas. It can do a lot of damage. So it's really bad if these things start finding a way around what we usually can do. So usually with staph infections, we see the antibiotics that are being prescribed are nafcillin, cefazolin, dicloxacillin, clindamycin, trimethoprim sulfamethoxazole. We're going to call that one good. Doxycycline. But with MRSA and VRSA, which is vancomycin resistant staph infections, which are also a thing and also really bad. We have to use other treatments. We have to use usually a combination of a lot stronger antibiotics, like I talked about in the start. But this is bad because that means that they're also slowly gaining resistance to the even more powerful end of the line antibiotics that we don't want them to get resistant to. And so what you'll usually see relating to staph infections, we see surgeons, health researchers, and all sorts of doctors, medical primary care, ER, a lot of people deal with staph infections because they're pretty common, but with MRSA especially, it's getting more and more common that we see those, even in just primary care facilities, because people think that it's just a normal staph infection and it turns out to be resistant. It's not good. We see surgeons, they're actually cutting out dead, dying, or infected tissue from where the staph cells have affected your body. We see all sorts of doctors prescribing antibiotics, all sorts of kinds, to try to treat these infections properly. And we also see health researchers trying to find vaccines and other ways like phages to get around these, to try to find new ways to attack and destroy staph cells. Anyway, I'm already tired. I don't want to do this. Follow Caleb's Carrots on Instagram, and I'm gonna put in some epic music now and go to the bibliography. That's what it's called. Dicloxacillin. Dicloxacillin. Clindamycin. Doxycycline. Doxycycline. Clindamycin. There's something wrong with that. Just like my brain. Okay. Some torp of some HACO or that's not what we call HACO. That's what we call healthcare associated or HO. Through healthcare associated MRSA or staph infections. Okay, how can we kill this thing? How can we pop it in the head a little bit faster next time? How can we execute it next time? How can we just AC-130 gunship it? MRSA, it's pretty bad. It's pretty bad. Just to say a little bit. Just say a little bit. It's pretty bad. So what we see. So if you get a small scrape